Hello dear friends, myself Sonigra, and today in the subject of mechanical drafting we will discuss a chapter titled as projections and sections of solids. Previously we have discussed about the concept for projections of solid, and today in subsequent sections we will discuss about the sections of various solids, how to draw the sections, why it is drawn, and the procedure to draw true shape and sectional views of the project of the solid. The first objective for today's presentation is to understand how to draw sectional views of the solid, to draw true shape of the section, to solve the basic and typical problems based on sectional views, and to identify need of sectional views. In this outline, today we will solve the problems and the theoretical background based on sections of solids. What is sectional view? The first question arises in our mind that what is sectional views? So the definition of sectional view is like this: an object, here a solid, is cut by some imaginary cutting plane to understand the internal details of that object. The action of cutting is called sectioning of a solid, and the plane of cutting is called as sectional plane. So whenever some intrinsic parts are there and internal details needs to be expressed, we used to have sectional views. In industries, the drawings are made with the sectional views to show the cross section of the object. There may be two different types of cutting planes which we have to study in present chapter. First is that cutting plane perpendicular to vertical plane and inclined to horizontal plane. That would be the one cutting plane. And second is the cutting plane which is perpendicular to HP and inclined to vertical plane. So in any problem, first we have to think about which type of cutting plane is given to us, type 1 or type 2, and based on the given cutting plane we have to draw the view of that cutting plane. We have to select proper view for that cutting plane, and accordingly further steps should be taken. Now first type of cutting plane, a cutting plane perpendicular to vertical plane and inclined to horizontal plane. Now how to draw this kind of plane? This section plane appears as a straight line in front view, as it makes an angle of HP. In front view, this plane will appear just as a straight line. This is the case for the cone. Observer is looking from the top, and this cutting plane makes some angle with horizontal plane. So in front view, this cutting plane is shown with the section line or sectional plane in front view. And here, as far as possible, we should assume that the upper part is removed, or otherwise the smaller parts should be removed. It is the normal conventions. In this section, the observer is looking from the top, so we assume that the top part is removed and the object which is away from observer is retained with us. Now second type of, in this first type of cutting plane, after locating section plane in front view and top view, front view or top view, whichever is applicable, the part towards the observer is assumed to be removed. As far as possible, the smaller part is assumed to be removed. Now second type of cutting plane, type 2, in which the cutting plane is perpendicular to horizontal plane and inclined to vertical plane. This section plane appears as a straight line in top view, as vice versa to first case. Here, if it is given that the cutting plane is make some angle with vertical plane, then it will appear as a straight line in top view, like this. For this case, as the cone is given here, observer is looking from top, so we assume this is the section plane is visible in top view as a straight line, and sectional front view would be there. Assume lower part is removed in this case. because it is smaller one, so it's a normal convention that we should remove the part which is smaller in the solid. Now important terms in sectioning. This is the normal sectional views of square pyramid, and what are the nomenclatures which we will use in this section, that is written over here. The first one is section plane. This plane is called as section plane or cutting plane. This is for top view. Arrow is shown that the top view is looked from here. This is the true shape. This one is true shape of the section. This is the section lines which is drawn at an angle of 45 degree to the reference line, and here reference line is XY line. It also shows the sectional top view, this drawn below XY line, and this is the apparent shape of the section. Apparent shape means it's not a true shape. Whichever shape is visible in that particular view, it is called as apparent shape. So it is represented over here. Now typical section planes and typical shapes of the sections that we are going to represent over here. The first case, this one. Here the solid cone is taken as a solid, and if this cone is cut at certain angle with the cutting plane, and the cutting plane, if that cutting plane passes through the apex point of this cone, then this section plane is to be visible in front view like this, and this would be the cutting portion. If you cut the cone from apex point, a triangular shape would be there. Second cutting plane, certain angle, section plane through generator. Here the section plane cuts the generator of this cone, so the elliptical shape would be visible. Then third case, section plane parallel to end generator. Here this cutting plane is parallel to this generator, end generator, so the shape which would be here, that is parabola. The cut portion would be parabolic in shape. Fourth case, section plane parallel to the axis. So here this is a cutting plane or section plane, this is parallel to the axis of this solid, so the section plane or the true shape of the section would be hyperbola. So here three various curves are there: ellipse, parabola and hyperbola. So these all curves are taken from cone sections. So these three curves are also called as the conic section or conic curves. Now this is the cylinder. If cylinder is cut at certain angle in such a way that the cutting plane passes through the generators, and this cutting plane makes some angle with this circular base, then its true shape would be elliptical shape as represented over here. So this cylinder is cut through the generators. The next case, for square pyramid, through all slant edges cutting plane is passing. This may be any kind of pyramid. In all the cases, if the cutting edges or the slant edges are cut by the cutting plane, here appropriate shape would be there. Here trapezium is there, so if pentagon is there, then here 5 points would be there and true shape will be accordingly. So these are the few cases and typical section planes and typical shapes of the sections which is represented over here. Now terms of conventions. Now what is the name of various conventions? This is the portion removed, this one. It is shown by this dotted line. This is a section plane or section line. This is section plane is shown by this blue color, this cyan color, and this square with the white color represents the section. This is front view and this is sectional top view. In front view, this is section plane AA, and this is the true shape which is represented by hatching section lines, this one. And this is the pictorial view of this object. Now types of sectional front views. The first type, the vertical plane, vertical section plane, this one. First is that the cutting plane may be vertical like this. It means that it's parallel to vertical plane and perpendicular to horizontal plane. So it will be with this cutting plane would be visible as a straight line in top view, and its appropriate sectional view would be visible in front view like this. Here the cylinder is there, so here this is the 3D view of a cylinder sectioned by the plane parallel to vertical plane. This is a cutting plane which is parallel to, this is a cutting plane which is parallel to this vertical plane. The second case is there, the cutting plane is inclined to vertical section plane like this. So this cutting plane is perpendicular to horizontal plane and it makes some angle with vertical plane. So such kind of cutting plane would be represented like this. Here the cylinder is cut and it would appear like this. So in top view it would appear as a straight line which makes some angle with XY line, and in front view appropriate sectional view would be there. Now type of sectional top views, that was sectional front views. Now what's about sectional top views? So for that, this is a cutting plane which is parallel to horizontal plane and perpendicular to vertical plane. So here this is cylinder is cut with this plane. So what should be its front view? In front view this cutting plane would appear as a straight line, and in top view appropriate sectional view would be visible. Here inclined horizontal section plane is there. This, it may be parallel or it may be inclined at certain angle, so that would appear in front view like this. It is represented by a straight line inclined to XY line at certain angle. Now sectional views parallel to HP and perpendicular to VP. The case, here typical case is discussed. A cube of 40 mm sides cut by a horizontal section plane perpendicular to HP at a distance of 15 mm from top end. Draw sectional top view and front view of this section. So here cube is given, side length is 40 mm. So first we can draw its front view and top view. That would be square of side length 40 mm, and this is the case. Here a square cube is given 40 by 40 and cutting plane is this one, represented by this cyan colored plane. It is 15 mm away from top end. This is the top end, and from this top end it is at a distance of 15 mm. So this distance between this corner to this point number 1 would be 15 mm, and from this it is cut like this. This is horizontal plane, this is vertical plane, and this is the true shape. Now how to draw the two views of this section? It would be like this. This is a square below XY line of 40 mm dimensions. This is a square above XY line having 40 mm dimensions, and in front view this cutting plane would appear. So draw a straight line in the front view which is at a distance of 15 mm from the upper edge. From here this distance is 15 mm. Then after, by taking projections from all these 4 points, say point number 1, 2, 3, 4 to its top view, we can draw this sectional top view. Here section lines would be there which represents the true shape of this section. Now sectional view inclined to HP and perpendicular to VP. One another case. The case is given like this. A square prism of base side 50 mm and height 80 mm has its base on HP. It is cut by a section plane perpendicular to vertical plane and inclined to HP such that it passes through the two opposite corners of the rectangular face in front. Draw sectional top view, front view, and find the angle of inclination of the sectional plane. So the case is, given case is like this. You can see here a square prism is drawn. So top view would be square, front view would be a rectangle according to its height. Then after that it is given that a cutting plane passes through the two opposite corners. Here one corner is here, another corner is here. So the case would be like this. This is the front view, this is top view, and this is the isometric view or 3D view of given solid, and this is the true shape, which is rectangle in shape. Now sectional view perpendicular to HP and inclined to VP. One more case. The data is given like this. A square prism of base side 40 mm, height 70 mm is resting on its rectangular face on the ground such that its axis is parallel to HP and VP. It is cut by a section plane perpendicular to HP and inclined to VP at an angle of 45 degree and passing through the point 10 mm from one of its ends. Draw the sectional front view and top view. Here we forget about the dimensions, just we draw the case, how to draw it. The given case is like this one. A square prism is drawn over here. So first we have to draw a square, and then cutting plane is like this. It makes angle of 45 degree with HP. So it passes through the point at a distance of 10 mm from one of its ends. So this is one end, and at a distance of 10 mm from this end, draw a line which makes an angle of 45 degree with XY line, and appropriate shape would appear, which is represented over here. So I hope this case is also clear to you. This is the case, true shape of the section. It is representing the true shape. Here a square pyramid is there. It is cut by a cutting plane which is inclined to HP at certain angle and perpendicular to vertical plane. So its true shape would be like this. And here this auxiliary reference plane is parallel to the section plane that we can draw. And this we will discuss in subsequent examples, how to draw various auxiliary reference planes. Now procedure for true shape. This shows the 3 steps how to draw the true shape that we will do in the next example. And the data is given for example number 1 like this. Now after discussing this theory, let me solve some examples based on sections of solid. The first example, data is given like this. A square prism of base side 50 mm and height 80 mm has its base on HP. It is cut